Okay, in this worksheet we're going to focus on graphing inequalities and doing some problems that involve scatter plots. We're going to graph inequalities first, so we're going to do a couple examples. Alright, if you remember, here are the steps for graphing inequalities. So the first thing you want to do is make sure the inequality is written in slope-intercept form. And then you want to graph the boundary line. You're then going to pick a test point, and then you're going to shade either away or towards the test point. Alright, so for the first one, we have y less than negative 2x plus 4. Right. This is nice because this is already written in slope-intercept form. Remember, slope-intercept form is something that looks like y equals mx plus b. Alright, now this in these problems the equal sign is obviously going to be an inequality sign, but notice how you have the y by itself, then you have your slope and your x, and then your b, which is your y-intercept. Alright, so it's already in slope-intercept form, so we go to step number 2, graph the boundary line. Alright, so you're going to have to plot the y-intercept, which is, it's 4. So we're going to go up along the y-axis 4 units and put a dot. And then our slope is negative 2. So remember that slope equals rise over run, and that equals negative 2 over 1. So I'm going to go down 2, and I'm going to go over 1. Which will put me right here. And then I can go down 2 over 1. Alright, so I got 3 points. All you need is 2. But we did 3. Now, remember that less than and greater than, you're going to connect the points with a dotted line. Less than or equal to, greater than or equal to, you're going to connect with a solid line. So here I'm going to connect with a dotted line. Alright, now you are going to, step 3, pick a test point. Usually that test point is 0, 0. We're always going to pick 0, 0 unless the boundary line goes through 0, 0. So here's 0, 0. And what we're going to do is we're going to plug in 0 for y and 0 for x. So we have y less than negative 2x plus 4. We're going to plug in 0 for y, and we're going to plug in 0 for x. Okay, so we have 0 less than 4. Is that a true statement? Yes, it is. 0 is less than 4. Because it's a true statement, we shade toward the test point. This was your final step. Alright, so if we look, what graph does this match? It matches A here, so A is your answer. Okay, now for number 8, this is a little bit harder because it's not written in slope-intercept form yet. Right, so we have to put it in slope-intercept form. So we have 5x minus 2y greater than 6. So step 1, put in slope-intercept. So we got to get this by itself. So we're going to subtract 5x from both sides. So we have negative 2y greater than negative 5x plus 6. Alright. Now what we're going to do is divide by a -2 both sides to get the y by itself. I have to divide each term by -2. So I have y. Now, whenever you multiply or divide an inequality, when you by a negative, you have to flip the sign. So it's now going to be less than. And then we have -5 divided by -2. Well, that's a positive 5 over 2. X. And then we have 6 divided by -2. That's going to be a -3. Alright, so here is my inequality in slope-intercept form. Now, let's graph this. Alright, so the y-intercept is the first thing that we plot. That's -3. Alright, and then the slope is 5/2. So slope equals rise over run. So it's 5/2. So it tells me I got to go up 5. 1, 2, 3, 4, 5. And then I have to go to the right 2. Okay. Now I'm going to connect with a dotted line because that is less than. I'm going to pick a test point, 0, 0. Okay, now I'm going to plug in 0, 0. So y less than 5/2 x minus 3. So 0 less than 5/2 times 0 minus 3. So 0 less than -3. And the answer is no, it is not. So you shade away from the test point. So that's all this area right here. Okay? And if you look, A, B, C, and D, you'll notice that A is going to be your correct answer again for number 8. Okay, in the last part, you're going to have a bunch of scatter plots, and you want to identify the relationship as either linear, quadratic, or exponential. So linear, if it looks like a line, so if it looks like a line, that's linear. Alright, now quadratic and exponential. So quadratics are U-shaped. Alright, so quadratics either look like that or they look like this. Alright, they're called parabolas. Exponential graphs, they look more like this. Alright. Now, when you look at this worksheet, it can be tough to tell the difference between a quadratic or an exponential, but look at how it finishes. So like, let's look at number, let's look at 14 and 16. So if you look at 14, notice how it looks like it's increasing and then it kind of starts to hook back down a little bit. That's an example of a quadratic. Now, in number 16, it looks like it's kind of half of a U, okay, but it doesn't kind of come like this. It doesn't kind of have that little hook. All right, so we would say that this would be exponential. All right, so 11 through 20 you have to identify, again, is it linear, quadratic, or exponential? Linear, straight line. Quadratic, it's going to be U-shaped, or it may increase and look like, and then kind of like plateau there and kind of work back down. So if you see, if it ever looks like it's coming back down, that is quadratic. If it just kind of goes up and there's no indication that it would come back down, that's going to be exponential.